Okay, so here we go. We're going to do factor by grouping. And you try factor by grouping when there is 4 terms. It doesn't mean it's always going to work, but that's like a key, whereas before we only had 2 or 3 terms. Okay, so order the terms from greatest to least degree. The degree is the power. 3, 2, 1, 0. Got it. From the first 2 terms only, factor out a greatest common factor. So see how I have it underlined? I don't like to put parentheses because that means multiply. We're not multiplying, we're factoring. So 2 is not a common factor, but x squared, right? But they both have an x squared, and 3 is not common. So I can only take out an x squared, and then I will have 2x plus 3 times x squared, so 3. Okay. Now from the back 2 terms, the greatest common factor, hey, if there's a negative here, you got to take out the negative. Okay. And 8 and 12, let's see, 2, but there's a bigger one. 4. Does 8 go into 12? Nope. So greatest common factor is 4, parenthesis, and negative 4 times what is negative 8x? Negative 4 times 2x is negative 8x. Negative 4 times what is negative 12? Negative 4 times positive 3 is negative 12. Okay, how do you know if factor by grouping works? What do you notice here? 2x plus 3, 2x plus 3. Step 2 should produce 2 different groups that now share a greatest common factor. 2 groups, but now the greatest common factor is 2x plus 3. Factor that greatest common factor out of each group. It's a little silly. It should feel silly. That greatest common factor is now this thing underlined in orange highlighter. So we're going to factor that out, and we're going to put that term in front. Okay? I'm going to look for a different color pen, My desk is a mess. 2x plus 3 goes in front. Okay, I did that. Well, every time we take out a greatest common factor, don't we start a new parenthesis? Every time, right? We took this out, we start a new parenthesis. Okay, what's going to go? What's going to go in there? Write what remains from the 2 groups in a separate factor. Okay, what remains? What does that mean? If I took this orange piece out, what would remain? The x squared. Yeah? And if I took this orange underlined factor out, then what would remain here? Minus 4. Okay? So we take the common thing and write that in front, and you take the 2 pieces and write that in the back factor. And then you ask yourself, can I factor some more? Can 2x plus 3 be factored anymore? Nope. Can x squared minus 4 be factored again? Yeah. X minus 2, x plus 2. And we're done. Let's do another example. Here we go. Follow the steps. Order the terms from greatest to least degree. 3, 2, 1, 0. From the first 2 terms, factor out the greatest common factor. These first 2 terms, what's the greatest common factor? X squared. Great. 2x plus 1. Check. From the second 2 terms, factor out the greatest common factor. Greatest common factor in the back is negative 9. Minus 9 times 2x. Negative 9 times 1 would give me back negative 9. Step 2 should produce 2 different groups that now share a greatest common factor. That's how you, isn't it funny how I write my 2's differently? I don't know why I do that. They have a greatest common factor. What do we do with that greatest common factor? We're going to move it to the front. So 2x plus 1. So we're literally taking this out of each, the first group and the second group. And when we factor out a greatest common factor, we start a new parenthesis. and we get x squared minus 9. All right. Can anything be factored some more? Yes. 2x plus 1, x squared minus 9, x minus 3, x plus 3. Factor each of the following. Oh, my lights. There we go. Okay. I need you guys to try this, okay? You try. If you watch me do it, you think you're learning, but you're not, okay? You have to try it, and then we'll check our answers in class, I promise. You try these on your own. Pause the video. Did you already do those? Okay. Here's what we're going to do. This is an exploration. Sorry. This is an exploration with a big conclusion below. Okay, this is good. So, I'm glad we did that quickly. Am I still on? Is this still recording? Let's get to work. Factor each of the following polynomial functions whose equations and graphs are provided. Oh, cool. Okay, so here's the function, and then here's the graph. Ready? Are we supposed to factor? Factor. Capital F. Ooh, scary. It's like Father F. What do we always check for first? Well, first of all, does this have 4 terms? Does it have 4 terms? No. So it's not going to be factored by grouping. Okay. So does this have a common factor? Yeah, I see a 3 is in everything. And is there a common x in everything? Yes. So I'm going to take out 3x. When you take out the greatest common factor, you start a new parenthesis. And 3x times x squared gives me 3x3. Okay. 3x times 4x would be 12x squared. 3x times what is 12x? Just a 4. After you factor out the greatest common factor, you say, can I factor again? It's not a difference of 2 squares. It's not a sum or difference of 2 cubes, but it is a trinomial. So this trinomial I can factor twice, or into 2 groups. So what multiplies to get 4 and adds to get 4? Plus 2 and plus 2. We're done factoring, yes? How many factors do we have? We have 1, we have 2, we have 3. Let's explore the graph. All we're going to do is answer these questions. What is the y-intercept of the graph? Okay, let's see. We have an arrow, we go up, we go down, and here is our y-intercept, what point is that? 0, 0? Okay, 0, 0. What is the constant term in the equation? Constant means no variable. So let's go to our equation, and x, x, x. What's the constant term? Is there a number here with no variable? Don't say it's 4, because that was after we factored. The constant term, I think, is 0, right? There's nothing there. So you're supposed to make a little connection there. Okay, y-intercept, constant. And we factored. We did everything we were supposed to do, yeah? Okay, let's keep going. Example G. Here we go. What are we supposed to do? Factor. Now, does this have a common factor? Is there something in everything? No. Is it factored by grouping? No. Difference of 2 squares? No. Difference or sum of 2 cubes? Nope. There's just 3 of them. So if there's a trinomial, that's going to go to 2 groups. Now, what multiplies to get x to the 4? X squared times x squared. And if you go, could it be x and x to the 3? It could, but then that wouldn't add up to an x squared in the middle. Do you see that? Okay. What multiplies to get positive 4, but adds to get a negative 5? Multiplies to get a positive 4, not 2 and 2, so it has to be 1 you know, here's 4. 4 can be 1 times 4 or 2 times 2. 1 and 4 will give you that 5. And what are their signs? The signs have to be the same, and they both have to be negative. Okay, can either of these be factored again? Let's see, can x squared minus 1 be factored again? Yes, it's a difference of 2 squares. Remember, 1 is a perfect square. The square root of 1 is 1. What about x squared minus 4? Can that be factored again? X minus 2, x plus 2. Whoa, 4 factors. Oops, I said 4, so I wrote 4, but it's supposed to be 2, right? What is the you already asked me that in the previous, what's the y-intercept of this graph? Let's see. Down, up, what point is this? 0, 4. Okay, what's the y-intercept of the graph? 4. What's the constant term in the equation? Well, the constant term is the term without an x. X, what number has no x? 4. Ooh, so they were the same here and they're the same here. I wonder what we're learning. And we're in explorations. When you explore the math problem and you come up with an explanation. Okay, example, that's H. Do we have a common factor? No. Is there 4 terms? Yes. So when there's 4 terms, what technique are we going to use? Do you remember? We're going to use factor by grouping. That's what we started this video with, okay? Factor by grouping. And I need a little bit more room, so I'm going to move down here. So common factor in only the first 2. The 2 and the 5, you can't factor those out. So look at your x's. We have a common factor of an x squared. Oh my goodness. Oh no, it's ruining my video. This sign. I'm sorry. I don't know what you missed, but here we are. Factor out the x squared. Now I have to hustle. 2x plus 5? Yeah? Okay. You guys, this is tricky. It looks like nothing can come out, but remember when there's a negative here, you have to factor out a -1. I know that's weird. I know you haven't done that a lot, but get used to it. So if we take out a -1, 2x plus 5. Do you agree? Okay. Now what do we write in front? The common factor, 2x plus 5. And in the back we go x squared minus 1. Can this be factored again? Yes, because it's a difference of 2 squares. X minus 1, x plus 1. And let's see what was the y-intercept of this graph. This y-intercept is, it's on this line, and it looks like -5. What is the constant term in the equation? -5. What connection do you see between the equations of the polynomial and the graphs of the function? The constant term of the equation will be what? Will be the y-intercept on the graph. There's another big connection that I'm going to have to share with you tomorrow because I'm out of time. Thanks for watching.